Legendary astronomy explainer Carl Sagan once said, "The size and age of the cosmos are beyond ordinary human understanding. Lost somewhere between immensity and eternity is our tiny planetary home." Just how vast is the universe we live in, and where does our pale blue dot rest amongst the giants that inhabit it?
So Derek, the universe is really big. The end.
It is
It's the end
huge.
of this segment.
Thank you. That's all we need to say.
That's all you need to know. We use miles to traverse a continent or state, but those don't work as well in space because, once again, the universe is really big.
Yeah, exactly. Here we are on this planet. The planet is just so big, so we don't really have a need for, big measurement units because the planet is only so big. But once we step off the planet, then things start to change. I mean, we can go out to the moon. The moon is 240,000 miles away, so that's still a number we can sort of put into a nice package, 240,000 miles.
My mom's Prius has gone to the moon.
Has it really?
Yeah, she's
Wow.
past like 250 by now.
I'm
so.
impressed. But once we start getting further than that, then we start seeing some challenges. And it really is that the numbers just start to get too big.
Yeah.
Right, so-
I mean, how many zeros are you going to tack onto stuff?
That's a really good
outrageous.
question. How many zeros? So now we take the measure from the Earth to the Sun, right? So that's a number that most people know. 93 million miles is the average distance to the Sun. So that's a number that people keep in their head. But when we start taking these measurements out into space, miles is one thing, millions of miles is another. But beyond that, we really need some other container to describe these distances, because any real distance around this portion of the galaxy is still enormous. So the distance from the Earth to the Sun, 93 million miles, average distance, is described as one astronomical unit.
There you go.
So now we've collapsed things a little bit.
But beyond that, you really want to start thinking light years, which is the distance light travels in a year, which is 5.8 trillion miles. I always have to let that sink in because that's an astronomical amount of zeros.
It is.
Yeah.
It's a lot. And the next closest star is 4.2 light years,
Yeah, that sounds manageable.
but that's just the next closest star.
Right.
We're looking at objects that are hundreds of times, thousands of times that distance.
Wow.
So then those
Yeah.
zeros really become critical in terms of shrinking them down to workable amounts.
And it does make sense, too, that we use light as a unit of measurement because it's the fastest thing in the universe.
That's
If this
true.
makes sense to people, it travels at 186,000 miles per second.
Per second.
Which also translates to about 7.5 times around the Earth in 1 second.
Yeah.
Mind-blowing.
Now that works for me. So one of my favorite stars to think about is Sirius, brightest star in the northern sky. That's 8 light years out. All right,
Wow.
so not quite twice.
Yeah.
That distance, 8 light years out. And we can keep going from there.
Keep going. One of my favorite stars, also because it's a popular one, is Betelgeuse, this red hypergiant left shoulder of the constellation of Orion. Everyone's been excited for it because we're hoping it goes supernova.
Oh, yes.
Although there's not an actual number because I think astronomy works more in approximations as opposed to precision when you're talking about fast distances. So I know that Betelgeuse falls anywhere between 650 to about 725 light years away.
Right. We have to add that plus or minus factor to
exactly.
compensate for all kinds of
But
things.
it's like, it's in a ballpark.
Close enough. It gives us an idea.
Exactly.
Sure. Right. Okay. So how about if we take a star like Deneb, for example, another bright star of the summer sky. Deneb is on the order of 1,500 light years out.
Wow.
So that's still farther.
That's still further. The core of our Milky Way from us is about 25,000 light years.
That's a good one. That's a good
Yeah.
one. Sure.
And the size of the Milky Way, about 100,000.
We can actually see the next closest spiral galaxy to us with our naked eye. But it's way far away. It's 2.9 million light years away. So that's a long distance. That's a really long distance, almost 3 million light years, and we can still see it with the naked eye.
And it's still our neighbor.
It's still our neighbor, right? And that's a close one.
That's still a close
So there are
one.
many, many more that are so much further away than that.
Wow. Wow.
But if we go all the way out to the edge,
About 13.6 billion light years.
billion light years
Billion.
to the edge of the observable universe.
Right. But with the culprit of dark energy, things have gone beyond that. And some of that light will actually never reach us because the universe is expanding faster than that light from those edges of those galaxies can get to our eyes.
We've established that the universe is absolutely enormous.
That's right.
But where do we rate in that? You know, the Earth itself. How do we stack up against other planets?
You always have to compare everything in your category, right? So with over 4,600 exoplanets discovered so far, most being mini Neptunes, that would actually make us a little bit below average on a size scale.
Right, because Neptune is what, 4 times the size of the Earth?
Exactly.
Yeah, so that really makes the Earth
quite
undersized.
compared to most planets we've discovered so far.
So how about our star? I mean, the sun.
Yeah.
We see it in the sky every day. It's enormous compared to the Earth. I mean, how many? I often forget the
I
number
know.
of planet Earths that can fit inside the sun.
1.3 million.
See? How about that?
I have useless information in my
That's
head.
really good information, though, because it gives us a way to compare. So that tells us, it shows us that compared to us, the sun is really big.
Right.
How does our sun, though, stack up against other stars?
And
like Betelgeuse.
Within the scale of stars, on what is known as the HR diagram,
Oh, yes.
it's still below average.
Okay, so let's think about our galaxy then. Here we have this enormous collection, like you said, 100,000 to 150,000 light years across. That's big.
That's
and
big.
we have somewhere on the order of, what, 400 to 500 billion stars?
That's a lot. But compared to Andromeda, we're still smaller. Not by too much, but Andromeda, our neighbor, is a bigger galaxy.
Our closest neighbor, spiral galaxy.
Spiral galaxy.
So we're slightly smaller than that.
Yeah. Everything just seems to be hitting below the belt in this conversation.
does.
We're below average
Yeah,
on
it
every
does.
scale.
Well, now if we try to go bigger than that, I mean, so now we're into the class of clusters of galaxies. And I think now we're going to find ourselves to be a little bit more on par with other clusters of galaxies. I mean, our most immediate cluster, the local group of galaxies, is something like 45 galaxies all grouped together. And as we look around, we might see that there are clusters of similar number.
Exactly. When you imagine something like the universe, you imagine grandness and giant scale. But we all have to remember, though, the things that make the big shit are the tiniest shit. That's what we owe everything to. You know, potentially strings, subatomic particles, atoms. And these tiny structures are as mind-blowing to me as the large stuff.